The concept for Epartrade is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for Epartrade is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to epartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At Epartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of Epartrade. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
Epartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Welcome to Race Industry Now, the technical and business webinar series from Epartrade, presented to you by ARP and Performance Plus Global Logistics. I am Francisque Savignan, the founder and CEO of Epartrade, the global platform for the performance and racing industry. This is episode 228, and we're going to bring our special guest from Bestline Racing. With me this morning are Judy King, the co-founder of Epartrade, and our terrific host, Mr. Brad Gilly. Judy?
Well, thank you, Francisque. I don't know if everybody's noticed, we have had so many new suppliers and services jumping on board lately. It's been kind of exciting for me. They're all on our newsletters. They're all on this platform. So don't forget to reach out to them. That's the reason they're on this platform, to engage with buyers, dealers, engine builders from around the world. So on to you, Mr. Brad.
Well, thank you very much. And it's always exciting, especially when you get the emails that come in with the new people who have joined on Epartrade. So we appreciate it. And if anyone's joining us here for the first time today, we appreciate you coming on as well. We're going to have a lot of fun. The title of today's webinar, Friction Eliminators, How New Additives Reduce Friction, Heat, and Wear by Bestline Racing. And joining us are partners in Bestline Racing, Harry Anderson and Todd Cawley, and world-renowned tribologist and a frequent member here at Epartrade, Lake Speed Jr. So, gentlemen, I hope everyone's doing well today, and I know we've got a big webinar. We're going to talk a lot about friction eliminators. We're going to talk a lot about everything that we've got here on our topic, and we really look forward to it. And also want to let people know that for attendees who join in today and raise their hand, ask questions during the webinar, we're going to get you a free bottle of Bestline gun oil. So very excited about that. There you go. It's always funny with Zoom whenever you have a virtual background and other things disappear in it. So I get that. Well, Perry, being that you were showing us that, why don't you go ahead and start and give us an idea of what we're going to be talking about here today?
Well, we get to talk about, and you can hear me all right, right?
Yes, sir.
All right, awesome. Yeah, it's a topic that I've been following for a few years, and I thought I'd reach out to Lake and see what he knew about it. And he's way more informed, obviously, as I am. He's directly involved in this topic called LSPI, low speed pre-ignition. It's kind of a topic that hasn't been talked about too much. It almost looks like the industry wants to keep it a secret. Well, it's no longer a secret today. Lake and I are going to discuss that, but he's, like I said, he's way more informed. He's a true tribologist, a chemist in the oil business, as well as, of course, they manufacture high performance piston rings that are directly involved in this topic. And then, of course, my partner Todd, we have another company called DNL Chemical. Todd runs that division where we actually supply the components that go into any oil or grease worldwide. So he'll chat about that once we're done with the LSPI version and get all the questions answered that will probably come up once Lake starts to present a little bit.
Well, that sounds wonderful. And Todd and Lake, welcome. And I know, Perry, we have a video at some point. So just whenever you're ready for that, why don't you just let us know?
Let's go ahead and start that video. That'd be great. Thank you.
Hi, I'm Alex Michelberger, a technology manager at Lubrizol Additives Engine Oils. Fuel economy and emissions regulations are accelerating across the globe, and all in the industry have a role to play. For automakers, this means offering more fuel-efficient engine technology, and gasoline direct injection, or GDI engines, have become increasingly popular for this reason. GDI engines offer higher power density, meaning smaller engines running at lower speeds that can achieve higher torque and power for maximum efficiency. But there are challenges. One of the biggest is called low speed pre-ignition, or LSPI. LSPI is uncontrolled combustion caused by higher in-cylinder pressures and lower speed conditions created within the GDI engine. This uncontrolled combustion creates spikes in pressure, causing engine damage. Left unchecked, it can become a big problem. And it's not just the engine damage. LSPI prevents GDI engines from operating at peak efficiency. Automakers have so far addressed this problem by calibrating engines to spray excess fuel into the engine at the point where LSPI occurs, providing a cooling effect and preventing uncontrolled combustion. But spraying excess fuel means sacrificing fuel economy. Luckily, LSPI is a problem that lubricants can help solve. Big industry stakeholders are looking for ways to mitigate LSPI. A brand new engine test is under development within the proposed GF6 specification to evaluate a lubricant's ability to help mitigate LSPI. In the combustion chamber, oil that lubricates a cylinder wall can mix with unburned fuel. This mixture can form droplets. One prevailing theory suggests that LSPI occurs as a result of the uncontrolled ignition of these droplets. It's important to note that a lubricant does not cause LSPI, but numerous studies and publications have shown that engine oil formulation can increase or decrease the frequency of LSPI. Due to its random nature, LSPI has proved a challenging condition to test for. And since lubrication can play a major role in addressing this challenge, Lubrizol has taken the initiative to help develop a reliable test to measure lubricant impact on LSPI, enabling GDI engines to operate at their most efficient. We've worked directly with automakers and independent laboratories to help develop a reliable solution. Further, Lubrizol has independently developed and tested specially formulated oils to gain insight into the causes of LSPI. But additive solutions are only one part of the equation. It will take a balanced approach between additives, base oils, and the engines themselves to provide a reliable path to mitigating LSPI into the future. It's an important challenge. Tackling LSPI ensures that automakers can calibrate their engines for peak fuel economy, and that the end user can enjoy a boost in fuel economy along with enhanced reliability. Mitigation of LSPI is just one of the ways that the proposed GF6 specification raises the bar in engine oil performance.
Thank you very much. Very informative for sure. And Lake, let me just turn it over to you a little bit to maybe explain a little bit more of what we just saw in the video and when it comes to this lubricant specification.
Yeah, thanks, Brad. The great video, by the way. That really hit all the talking points we wanted to talk about today, which is kind of nice. As you watch the video, what they're basically saying is that because these are high compression engines, that's one thing about a direct injection engine versus just a normal port injected engine, is that these engines have, higher static compression ratios. And because of boost, they typically have higher cylinder pressures. So as most engine people know, that as you increase compression, as you increase cylinder pressure, you get closer to the edge of detonation. And that's basically what they're saying. Low speed pre-ignition is a kind of a fancy term for good old fashioned detonation. But what's different about LSPI than just good old fashioned detonation that we're used to is that old fashioned detonation just means, man, I burned a hole right in the middle of my piston because I just got a little bit too carried away with either my timing or my fueling or whatever. What's different about LSPI that they actually showed in the video, that it actually occurs from the sides. It's not burning a hole in the center of the piston. It's actually the pre-ignition is beginning at the edges or even in the ring lands. You saw that one picture where it had blown the ring land off the side of the piston. That's why Perry reached out to me, right? Because, hey, I'm the piston ring guy. Please don't kill my piston rings and blame us, right? It's if you're detonating your engine and killing the piston rings, it's not the piston rings' fault. It can't cause detonation. So what you're seeing is, and they mentioned in the video, it's the interaction of the unburnt fuel and the oil. And Brad, we've talked about this, in the oil analysis pieces, right? That we see it over and over again. High levels of fuel dilution correspond with bad things with your engine. Hello, here we are again. Same thing. Fuel is the enemy of your oil. Now, fuel isn't bad, but in this case, it's the unburnt fuel. Now, before we were talking about like vapor pressure of fuels and things like that. This time we're talking about the fact that with direct injection, and again, the video was perfect because it shows it. You only have about 180 degrees of crankshaft rotation for the fuel to go in. Now, in a carbureted or port injected engine, it's almost twice that amount of time. So there's less time for that fuel, that little droplet of fuel, to turn from a liquid into a vapor. And that's the key thing. We can't burn liquid fuel. There's got to be a vapor for it to burn.
Right.
So when you have that liquid fuel and it can interact with the oil, that's what provides the opportunity for bad things to happen, because we've actually done some testing in the past. I'll call it my previous life. We did a lot of work with Oak Ridge National Lab and General Motors. We actually were working on some things with this in regards to LSPI. And what we found was that the detergent level of the oil has a big impact. Now, they didn't call that out in the video. They said, hey, the additive package can play a role. Okay, it's the additive they're talking about is calcium sulfonate. It's a type of detergent additive in the motor oil. And there's usually three basic chemistries of detergent additives. So yeah, sodium, calcium, and magnesium. Two of those three aren't friendly for LSPI, and that's sodium and calcium. And you've already seen it in the last couple of years. This video must be a few years old because they were talking about GF6. Well, GF6 is already out. So the testing they were talking about creating, that's already done. So any oil that's an 8 API SP, that's the current spec, has to pass these tests now. And what that really has done is that pretty much eliminated sodium detergent from the market, at least for passenger car type motor oils. And the calcium levels have dropped, which is really important. Now, magnesium is kind of agnostic to LSPI, which is great. So that's what most companies have gone with, is a mixture of calcium and magnesium to create the detergency you need. But the really interesting part of this is that base oils, because that's all an additive, a motor oil is a mixture of base oil and additives. So the base oils typically have a lower octane value than the fuel. So it's the mixture of those two. And I think we saw in one of those videos there, they showed one time like a little bit of flying, because think about it, as that piston approaches top dead center, it's slowing down. And that's the key thing to understand here, is that you have oil in the ring package, right? And if you think about it, the oil ring, its job, because the ring package has really three rings. You got a top ring, that's compression. The second ring, its job is like partial compression, partial oil control. And then you got the 3-piece oil ring, and this job is 100% oil control. So it's trying to scrape that oil off. So there's oil being scraped up into those ring lands as the piston's approaching top dead center. But the piston is slowing down, so that oil has some inertia. And if it's diluted enough with the oil, those droplets of mixed oil and fuel can fly into the combustion chamber. And then that's where that detonation can happen. So what we really have seen is that the calcium detergent and the sodium detergent as well, they tended to have the ability to emulsify that unburnt fuel with the oil, and it would create this mixture that had a lower octane value than the fuel itself, which is why it would begin to ignite.
So Perry, where does Bestline come in on this? And, why are the additives necessary? And, maybe speak a little bit more about what Lake just talked about.
Yeah, well, it's not a direct correlation. However, a few years ago, when I started to follow nano lubricants more deeply and their impacts, and then I discovered the carbon nano lubricants that we call Diamond Nanolube, right? Those play a real important part in creating a better boundary layer between the parts, as well as higher temperature ratings and all that. So when I was looking at LSPI, it seemed like that nano lubricants can play a part in preventing the pre-ignition, right? That Lake was just talking about. And finally, there are tests. I mean, the GF6A and B rules, they were hard to test to until recently. They didn't have a way to define exactly what was going on, other than, we were blowing the tops of the pistons off at the ring glands. So we don't know for sure, right? It's an expensive test, and it's fairly new. But so Lake, we talked a little bit about that this morning too. How do you feel about nano lubricants being able to assist in that and solving some of that problem?
Well, it would be interesting to see, like you said, that's when we were doing that testing a few years ago, the nanolubes really weren't something that people were looking at, primarily because, as Todd knows, one of the things that's really been interesting with the development of the nanolubes is actually having them to be able to be stable in suspension. Nanolubes aren't new, but what happened was, in engine oils and things that were pretty complex with a lot of different chemistries in it, they didn't tend to be stable. They would drop out, which is why they had a place in grease, because grease, they wouldn't fall out. So
right.
They had great results in grease, but you really weren't seeing anyone really embracing them in engine oil technology just because they weren't stable. But it seems like the new technology really has changed that. That's something that, I was just last week, obviously I've been working with Todd for about a year now on looking at some of these nanolube technologies for some different applications. And the first thing I did was, okay, I'm going to mix up some stuff. I'm going to put it on the bench. I'm going to watch it for 6 months,
right.
See if it separates before we start getting down the road. Because last thing you want to do is go down the road and then find some great results, but then realize, well, it's not stable, so it's never going to last. So,
right. And
I can say that, that stuff's been sitting on the shelf for almost a year, and it looks just as good as it did the first day we mix it together. So the emulsion stability has been really great. Now, with that being said, we still have no idea what it can do, in terms of LSPI, because really what the long history says is that it really is detergent based. We had talked this morning a little bit, and it's kind of funny, Brad, that they call it LSPI, they act like it's new. I don't think it's new. That video was from the guys at Lubrizol a couple of years ago, 2018 actually. I gave a speech at the AETC, which was the Advanced Engineering Technology Conference. It was right before PRI, on LSPI, and we worked with the guys at Afton, which is one of the other major additive companies. They gave me some information in preparation of that speech that said that they were able to replicate LSPI in port directed engines. So not even a direct injection engine, they were able to replicate it. And I can tell you, we did it too, in some non-direct injection engines. So when I mention that is because if you go back, I remember in the early 80s NASCAR stuff, before they had compression rules. I mean, there's some guys were pushing compression ratios really high. And some guys were actually running aviation oils, which are non-detergent, by the way. So what I'm trying to say is there's anecdotal evidence that goes back decades that says when you get to really high compression ratios, very high combustion pressures, the detergent additive could play a role in triggering detonation. So this isn't something that's actually new. We just have a new name for it. Now we have a way to test for it. Yeah. And, from the piston rings perspective, one of the things that is really key is, that oil ring tension is the real key to how much oil you scrape off the cylinder wall. Because that's really where it boils down to. If I scrape a lot of oil off the cylinder wall, and there's very little oil for the fuel to interact with, guess what? The chances of you having LSPI are a lot lower, which is a good thing. Now, the trick is in racing is that people tend to want to put in a high viscosity oil because they're racing. And what you can see and back to the video gives us all the touch points. One of the last things he was saying is, well, we want to optimize for fuel economy. Well, optimizing fuel economy means lower oil ring tension. That's one of the things we talked about when we do like these NHRA trackside tech talks. Is we'll sit there and show you, hey, you know what? 30 years ago, the combined tangential pressures, the loads of a ring package was about 34 PSI. Today, we've got it down to about like 15 PSI. We've more than cut it in half. Well, what comes along with that? A little bit of oil control, which most people with late model cars know sometimes these things use a little bit of oil. Well, why is that? Well, it's because we've whittled down that oil ring tension the least we can go in order to maximize horsepower, maximize fuel economy, because it's one and the same. But the trick is, they mentioned in that test, it's hard to replicate it. Well, what we found in doing the development of that test, LSPI is more prevalent at cold engine temperatures. What's going on there? Well, all of viscosity is related to temperature. And Todd knows this really well, that the colder the temperature, the higher the viscosity. All oils thin out as temperature increases. So if you go get in your brand new direct injection car and you have a short commute to work, and when you get to the stoplight and you're sitting there idling, the car's only been running for about a minute, and then I'm late to work and that light turns green and I mash it, there's more of a chance for LSPI right then, because even if you have a 0 W20 oil in your engine, guess what? At 100 degrees Fahrenheit oil temperature, because that's about all that it is, about a minute into your running, that oil is thicker by a lot than a 20 W50 is. It's probably thicker than a Nitro 70 is at 200 degrees at your 100-degree operating temperature. That's what most people don't know. And then that poor little oil ring, guess what? Its tension doesn't change regardless of engine temperature. So it's designed to scrape that oil once it's warm, optimally. It's not scraping it optimally when the engine's cold. So that's where this issue really comes down to. So from the piston ring perspective, it's really about understanding how much compression ratio are you going to run? What engine temperature are you going to run? Now let's derive the optimal oil ring tension for your application. Then you can go rely on the chemistry guys like these guys here and say, okay, what's the optimal additive package for my application? So we can handle it from the mechanical side. The oil guys can handle it from the chemistry side, which goes back to what the video said, right?
Right.
The optimal solution isn't pixie dust. We wish there was pixie dust. The optimal thing isn't pixie dust. It's getting the right mechanical components together with the right chemistry. That's where the optimal performance and durability comes in. Now, one of the things, Perry, we were talking about this morning, was that old saying that we hear repeated over and over again in the industry. So why don't you tell them what we were talking about this morning in terms of that false mentality that there's a trade-off between performance and durability.
Right. Yeah. Well, it all comes down to lubrication, right? Yeah. When you're maximizing the amount of horsepower you're generating, it's going to require better lubrication. When you have a failure, it usually isn't just a mechanical part that failed because of pressure. It has to do with the lubricity, the boundary layer of the oil, you know, and are you banging mechanical parts together unnecessarily? But yeah, it's all about the lubrication once you get the mechanics, you know, the mechanical properties correct.
Blake, I also wanted to follow up on something you said, which I think is really important because you and I have worked on this for a year or so. Nanotechnology, we think, can solve a lot of these issues, but up until recently, you couldn't really pursue it because even though nanotechnology has been around for a number of years, the big problem was suspension, right? It wouldn't stay in formulation. And so what the exciting news for everybody in the nanotechnology and lubricant area is that now that's solved. Now we have some nanotechnology, some nanocarbons, some nanoceramics that are staying in solution, are staying in suspension. Now we can begin to investigate all the different places in lubrication that they can help. One of the things you brought up is that early on in the ignition process, the viscosity is different. Well, one of the things we've learned about nanotechnology is it really helps the friction coefficient curve early on in the curve when you're first starting. So some of these issues that we're seeing out there, we already know from a property situation, nanotechnology has the opportunity to really help out in those situations.
This is fascinating. It really is. I do want to remind folks, we're going to get to some of your chat questions as well. But if you do get a question in on the chat, you're going to get a free bottle of Bestline gun oil. So thank you, Perry and Todd, for that. And if you guys don't mind, there were a couple that even actually came in beforehand from Michael Colburn. And there's two questions here. So I'll get them out and then we'll divide them if we need to. Has anyone ever defined for you the meaning of diesel fuel lubricity beyond just the words? I've looked high and low from here to there for even a technical definition by anybody, and I've found nothing. Or put another way, outside of the ultra low sulfur diesel fuel excuse, do you know what causes diesel fuel to have poor lubricity? What is casual mechanism in the fuel that's causing the diesel fuel poor lubricity problem? And that's the first question. So I'll leave that out there.
Well, yeah, I mean, diesel fuel, and I'll answer part of this. I think Todd can probably finish up the rest. Diesel fuel, there's a wear scar requirement, right? So yeah, the ultra low sulfur diesel fuels have much less lubricity. So you have to add it to the fuel to get that lubricity back. Otherwise, you're going to have fuel injector issues, fuel pump issues, and all that sort of thing, which we're seeing, right? Especially in the large, the heavy truck environment. They're burning through fuel pumps, the high pressure, fuel pumps, as well as injectors. Todd, do you have something to say?
Yeah, no, Perry, you summarized it very well, but they actually measure the lubricity with the wear scar test. And the truth of the matter is that and I've been in refining, I didn't give my background, but I've worked in the refining industry for about 30 years, 20 years with Sinclair Oil. Refineries make diesel to the lowest spec typically. Whatever the spec is, that's the low. Hit that. We're talking about billions of gallons refineries make a year. Even a tenth of a penny makes a big difference in their profits. So when you buy diesel, understand it's typically to the minimum spec. Right. So that's where additives come in. That's where aftermarket additives come in. If you really want to improve that lubricity, there's a number of great additives that you can buy that will bring up the performance of the diesel. And I certainly encourage anybody that's going to invest money in diesel equipment, whether it be fleets or your own personal vehicle, just feeding it the minimal, which is what you get from the refinery, is always going to be a mistake. And therefore, you need to really look into adding quality diesel additives, which of course we have at Bestline as well. We will also continue to find out the newest and greatest additives in the marketplace. That's why Perry and I invented really and started DNL, so that we can be always in communication with all the great additives around the world and then bring them into the Bestline Racing portfolio. But definitely lubricity is a very big deal right now.
All right. And another question for Michael Colburn. At what point in the engine's life is LSPI a problem? When is it, when it's new or after it's in use? How many hours are on the engine when LSPI becomes a problem?
Blake?
It's right from the go. It doesn't have a home, right? Where it's like,
Yeah.
oh, I'm not happy here. I am happy there. It can definitely occur at any time in an engine's life. Yeah, there's direct injection is a really wonderful technology. The power density, like they said in the video, is fantastic, but there are some challenges related. It doesn't come with, there's trade-offs like in most things in life. You don't have fuel to wash the valves. So that's one of the issues that was coming up pretty regularly with direct injection engines, that the intake valves would carbon up. And so that would be a challenge to the engine. And of course, if it builds deposits, well, then there's more chances of detonation there because of you've got all the carbon built up on the valves. So there's really not a time in its life that is worse than the others. Now, I would say this, is that back to the oil ring perspective, a 3-piece oil ring is an expander and 2 scraper rails. And the scraper rails are what's actually contacting the cylinder bore. They have no tension on themselves. It's the expander which acts as a spring that pushes them against the cylinder walls. And then, of course, there's like a waffle shape. So it allows the oil to drain, the scraping to drain back. And then the piston has drain back holes in it. So that's where the oil can basically come off the cylinder wall and then go back through the piston. That's what you want it to do. You don't want it to just scrape and build up and be left on the cylinder walls or get trapped in between the ringlands. So that's where the piston guys have a role in this. And then crankcase vacuum, oil situations is a big deal there, because what you really want is, if you have crankcase vacuum, then you've got this pull where you can pull that oil off, back through the piston and down into the crankcase to get it off the cylinder walls. So that's the mechanical part of this, is that you want to be able to do that. But what I was going to say is that as you have these small detonation events, it's like a harmonic to that spring, and it can lower the tension of the oil ring, which now we started a downward spiral. Because once you have these events and you've taken the tension out of the spring, now guess what happens? You have less scraping, which means you get more oil, which means you get more detonation. It's just, it can go really bad really quickly. Ask me how I know.
well, here's like, this is a follow-up and it's directed to you, and maybe this applies here to what you're talking about. Does the thickness of oil ring play any role, meaning the size of the oil ring?
Yes and no. So there's a big confusion in the piston ring world of what we call standard tension. Well, there isn't a single standard tension for all oil rings. So this, like a standard tension 3/16 oil ring is about 22 to 23 pounds tangential force. Standard tension for a 3mm oil ring is about 12 to 13 pounds. So if you just use the word standard tension, it can be confusing. And now, to his point, from a 3/16 ring to a 3mm ring, yes, the 3mm ring can have less tension, but you can get low tension 3/16 rings that are the exact same tension as a 3mm ring. So really, if you have a problem or you're trying to build an engine and mitigate this problem, you really need to look at the actual ring tension. And then your piston ring suppliers, they all know this. I mean, this isn't like trade secrets. So you can ask them, hey, this is what I'm building. This is the tension that I want to get to. And then they can help you figure out how to get there. That's one of the things that our guys at Total Seal do all day, every day, is work with people to adjust the oil ring tension to their application, be it a dry sump system, a wet sump system. These, engine that runs really cold versus an engine runs really hot. These are the considerations you have to go through. So to answer his question is, yes, it does make a difference, but there isn't like on the box. It doesn't, it's not going to tell you what it is. You got to ask a question to find out.
All right, fair enough.
Hey,
All right. Oh, go ahead.
Yeah, one more thing I meant to ask Lake this morning and I forgot. Might as well ask it here. I've got I'm involved in NHRA with some friends in that business, and I'm watching the viscosity. These guys are starting to come off of their 90 weights and come down into the lower weight viscosity. How does oil ring tension play a part in that? Because some of these guys are running. I'm hearing that they're even on some of the pro stock. They're running 0 weights to gain more horsepower.
Well, yeah, they do. And the key thing really is operating temperature. Not long ago, we had a discussion, with a pro stock team, and they were concerned that for the cylinder home they were trying to achieve that, we're running this, 0 W oil, below any SAE grade spec. It's super thin. Maybe we need to have the surface finish difference. And what I explained to him, I said, well, here's the reality. Just double check me here real quick. When you go up to the start finish line, the start line, what's your oil temperature? Oh, so we chill the water down to about 50 degrees Fahrenheit and we start the engine up, and the oil temperature is maybe 70 degrees Fahrenheit. All right, what's it at the end of the run? Oh, it might be 100 degrees. Okay, so let's do the math here real quick. Your 0 viscosity oil at 100 degrees Fahrenheit is about 12 centistokes. That's actual measured flow number. Okay, 12 centistokes is a 30 grade engine oil. So if you looked at a turbo diesel engine running 15 W40 that has a operating oil temperature of probably about 240 degrees, your oil in that pro stock engine is probably slightly thicker than what that turbo diesel engine is.
Wow.
So you actually probably need a hone that's closer to what that turbo diesel has. And they were like, mind blown.
Yep.
So it's really not about looking at what that viscosity grade says. It's really about understanding the operating temperature of the engine and then working from there. Back to the video. How do you optimize performance and durability? We have to look at this as a system. Brad, you know what I'm about to say, don't you?
I do, yes.
Ring seal soup. Right? It's all working together. It's the viscosity of the oil. It's the tension of the rings. All of this has to work together as a system based on the operating environment. The more you define the operating environment, the clearer the picture becomes of what the right viscosity is, what the right additive package is, what the right oil ring tension is, back to what, Todd and Perry were saying about, the friction modifiers and things. That's when you're in racing, you want the lowest possible friction you can get. Yep. And those oils aren't going to live for a long time. So you don't really need a lot of detergents. You don't need a lot of the other stuff in there that goes into, say, a diesel engine oil that's designed to live for tens of thousands of miles. It has a completely different additive chemistry that's not better or worse. It's just right for the application. If you're engineering an oil for a true race application, you're going to get rid of the stuff that's about longevity in terms of not longevity of the engine, it's the longevity of the oil. Because the oil's not going to live very long. Now let's focus on maximizing friction reduction, maximizing extreme pressure, because back to the drag racing deal, is these guys are making more power and turning more RPM. You're seeing higher and higher loads. Even these engines aren't flat tappets that much anymore. Flat tappets are pretty, they're getting rarer and rarer, and because of a bunch of other issues, people are going to rollers. Well, what happens is people say, oh, I went to a roller, I don't need the good oil anymore.
Right.
Wrong. Your push rods are dying because you don't have the correct additive chemistry, because now you don't have that flat tappet interface, but you've got this push rod interface. And that's where you're starting to see things crop up. So where 20 years ago, the whole story was flat tappets, today really it's more about push rods and some of the other things in the valve train for the racing applications when it's highly loaded.
That reminds me a bit of, you talked about heat and what nanotechnology might be able to do. I had the opportunity a few years back to meet with a power plant in South America that ran big marine engines to produce electricity. And it burnt through the oil really quickly, right? And basically what they were trying to do is say, what can I put in the oil that will lower the temperature and lower the friction so I can create more electricity? And so all we had to do is actually add some nanoparticles into that oil as an after treatment. And they immediately did a 1-month test and saw that with the nanotechnology in the lubricant, reduce the friction coefficient, they were actually able to run the engines harder, produce more electricity, and not hit that temperature spec that they had to stay under. So really meant millions of dollars in extra electricity to that power plant. So those are some of the little subtleties that you think about when you're doing racing or producing energy. How can I reduce that friction coefficient with my lubricant?
Yeah, that's right. The other thing that comes up often, I have customers calling me about, they're increasing the viscosity, right? They're buying viscosity modifiers because they're hearing a tick in the motor. And I have to remind them that the oil is actually your primary coolant, right? Between all the parts, all the push rods and the bearings. So if you make it thicker, it's going to move more slowly and the heat transfer will be less. So, just stay with the viscosity that you're on a conventional vehicle, of course, your daily driver. That's what we're talking about. But yeah, Lake, do you have any comments on that about, people that have a tendency to increase the viscosity thinking it's going to solve a problem in the motor?
Well, we've seen it, several times before, and that back to the total seal side.
Yeah.
I don't want to see someone running a thicker viscosity oil than they have to, because now back to we're going to need to probably bump up oil ring tension and do these things that are going to rob efficiency. And back to what Todd's saying, we're always preaching efficiency. It's if you can get the job done with less static load, with a lower coefficient of friction, you're going to get the job done more efficiently, which means your parts are going to last longer and you're going to spend less energy to do it. And that's the ultimate goal. We wrote an article recently, me and Matt Hartford for NHRA for the National Dragster. It's like, can the technology that lowers your ET improve your business's EBITDA? And the answer is yes.
Yes.
100%. Todd just gave a perfect example of that, at a power generation plant. So it all applies. So really, I can go back several years ago and think of a situation with an engine builder that they had their engines running really hot and they've been running a 1550 and they were calling up asking, hey, maybe we should go up in viscosity because we got these really high temperatures. And my answer was, no, go the other direction. Go down to 10W30 or 10W40 actually. Right. And fortunately they had enough confidence in me that they listened to me and they went that direction and it actually solved their problem and they saw the oil temperature go down, stupid series.
Like, let me also interject in here real fast because I want to make sure everybody gets the free gun oil that you also don't, if you just want to raise your hand on the platform, we'll go ahead and send free gun oil additive if you just do that as well. You don't necessarily have to ask a question.
Yeah, that's right. And Brad, it looks like we have some people that have some questions. So let's answer some questions now. And,
that sounds good. We'll just try and go in the order in which they come in. We had Gary Lasota said, have you ever worked with Pennzoil gas liquefaction oil in combination with the nanotechnology? Like the Pennzoil Platinum brand uses natural gas to make the synthetic.
Yeah, one thing I want to make clear is we represent a variety, DNL Chemical represents a variety of different additives and nanotechnologies. We're always going to be current. In my career, I've definitely seen some tests done specifically in that lubricant, and I've had very good reductions in the coefficient of friction and the wear scar. So we've seen nanotechnology perform very well in those products. I can't tell you a lot about what might be happening upstream because we have NDAs in place and different things. I did want to use that segue to answer a question I get all the time though, which is, if this is such great technology, why isn't it already in all the big oils? Why isn't it already in with all of the big additive manufacturers? Lake will know this as well. But the industry is really controlled in a lot of ways by 4 or 5 very big additive companies. I have a lot of friends there. They're great companies, but they tend to be very slow in bringing in new technologies. for good reasons. They're very big. It's an oligopoly. They don't necessarily aren't driven to have that happen because their sales will remain fairly constant. So it's up to the smaller companies to really help introduce newer technologies. The bigger companies will eventually get to them. And that's what DNL Chemical and Bestline's all about, is being out in the world, going to the conferences, finding the newer technologies, vetting them, getting them to people like Lake that like newer technologies, want to try them out. And so that's really the challenge of bringing new technologies into the lubricant world.
That's right.
That is great. All right, another question. Dealing with FPT multi-air engines, we're seeing burnt valves on a weekly basis. Will this added technology help prolong that issue?
We think so. That's where getting it into the hands of the people that are formulating, one of the questions was about really using this as an aftermarket additive. We also want to sell and are selling nanotechnologies to formulators that are working on those issues. So we certainly think from an understanding of nanotechnology and the benefits of how it might work, that it would help with that. Lake, you might be able to speak better to that because I know you're testing some different nanotechnologies, but we absolutely think it could help solve those issues.
I'm assuming they mean on the multi-air engines that might be some type of compressor. And so it's the oil obviously is a huge part, Todd, on that is having the correct additive package, having the correct base oil type. All that matters is that certain applications are very sensitive to chemistry, especially when it comes to valves, and air compressors are really sensitive to having the correct base oil and the correct additive package.
Yeah. I would encourage that person to, go to our website, give us a call. We're working with lots of different formulators, and maybe we can come up with a specific formulation. As Lake has said, it's about getting all those components together in the right mix to solve that issue.
Okay. Here's another quick question. Additional fuel and lubricant treatment additives are discouraged by lubricant companies. According to them, by adding any additive, it will disbalance their formulation. You sort of spoke to this just a second ago, and have a negative effect instead of giving the benefits. Please clarify. And by the way, that's Ahmed Mazar Badir from Ontario, Canada. And I hope I pronounced your name right.
I can go first on that. And then I know Lake is in that area as well. But basically, big additive companies, big oil companies, certainly big fuel companies normally discourage you doing anything to their products, right? They want to suppose that it's already a perfect product. They've already formulated it. And there is some needs to be careful. But when we sell an aftermarket product, typically we are testing it in everything. We are watching how it performs. We might be adding a component of nanotechnology. In the fuels, we might be making the diesel better. We might be making the lubricity better. We might be making the detergency better. So generally speaking, just to say you shouldn't ever add anything to a product is not correct. Be careful though, obviously, and make sure you know what you're doing. But most fuels are fine to add anything to. The nanotechnology we have for engine oils, as you have oil in your engines, it starts to burn up, it starts to decrease, TBN numbers can change. So there's some good reason to add to it. And I would just say be careful, but we're comfortable with the products we're supplying in the aftermarket to add them. And then remember, we're selling a lot of this also to formulators like Lake, so they can already have it in the formulas that you receive. Like,
yeah, well, I want to quickly add to that. The spec on the oil manufacturers, anybody that has the product on a shelf at a retail store, they're meeting a minimum spec. You don't see a maximum spec, right? So it's all cost. It's all driven by cost and whatever they're trying to achieve. The reason I started Bestline Racing is to give a much higher degree of performance. Right. I've been that consumer that you buy a bottle and you go, I hope this does everything it says, and you use it and you can't tell if it does. One of the main things that I have done is, of course, make myself available to everybody, all of our customers, and I guarantee that it's going to work. You'll notice the difference because of the additive packages that we put in it. It isn't just smoke and mirrors, right? Because we are obviously, in that snake oil business. So people tend to disbelieve us to start with. But that's why I started the company is to to actually provide a product that has the proper chemistry formulated by tribologists and tested before we bring it to market. And what's on the label actually, it actually does what we say it does, right?
You have anything to add to that, Blake?
Yeah, sure. So I think it's really important to make a dividing line between oils and fuels. Because it's not fair to treat them one and the same within this thought process. When it comes to fuels, I'm gonna go back to what Todd said from the refinery side. He was spot on. Refineries run to make to the minimum spec. They have a specification, and any point of octane, anything costs them money. And over the scale, it can be a lot of money. So when it comes to fuels, there's, we call it LAC, lowest additive concentration. That's your normal fuel that you get at the stations. Then you can have what's called top tier fuel. So the top tier has a little bit higher spec. So when it comes to the fuel additives, I'm 100% on board for putting fuel additives in. I use fuel additives myself. Polyethylamine-based fuel additives are wonderful for cleaning intake valve deposits, cleaning combustion chamber deposits. They're excellent for direct injection engines. So that kind of chemistry is wonderful. Now you don't have to use it every single tank, those kind of things, but it's good to have a fuel additive. I'm all for that, especially diesels. That's a big deal because in the US, we don't have, well, I guess they just now came out with top tier diesel a few years ago, right, Todd?
Right.
I've never seen it advertised anywhere, but everywhere you go in Europe, you go to any pump in the UK, there's standard diesel and there's premium diesel. And the premium diesel has the higher detergent package, higher lubricity, and all that. You really don't see that here in the US. So for diesels, all about putting in fuel additive for that.
Right.
That's a different question. And when it comes to the oil, back to what Todd said, is you have to be careful when you put an additive into an oil. I'll say, especially for racing products, where people crazy like me have pushed the solubility limits and we've gone all the way to the edge as far as we can go, and you put something else in there, it could throw the balance off. That's why I'm hesitant to say, I'll just go throw anything in there. You're never gonna get me to say that, because you got to be careful. Because people like me, formulations we came up with, we're going to push the limit. Now, that doesn't mean every oil is going to be that way. And I think that's kind of the real point, is that if you're going to decide to put something in a formulated oil, you need to do it a forethought. You need to really think about it, ask some questions, maybe do some studying, maybe do like the blends test that I did to make sure, hey, is this stuff going to work? Because I've seen situations where someone put something in and it freaking turned into grease in 5 minutes.
Yep.
Because the chemistries are so whacked out. And you hear that in the market, right? That someone says, well, I used XYZ, additive, and I picked up 5 horsepower. Another guy says, I used XYZ additive, I lost 5 main bearings. Well, who's lying? Well, neither one of them are. The reality is, someone did their homework and they worked it out, and this combination works better, and that's okay. Somebody else, they just decided they bought that off the shelf because they heard it was good and they put it in. They didn't think about it, and it caused a problem. So as long as you are thinking about what you're doing and not just following the crowd, you're probably in better shape.
Exactly.
Excellent.
Awesome. All right. Does lubrication on cylinder walls apply to a flat 6 the same way it does a V8?
No, because a flat engine does not have gravity assist the same way a V8 engine does. So that's the one thing about a flat engine here, where you typically have to be a little more conscious of oil ring tension. And so back to cylinder wall finish, I hate to always feel like the guy that goes back to having a profilometer and yelling about cylinder wall finish, but it's really a big deal that with the flat engine, there's oil consumption can be an issue. And where that really relates to is the fact that there are ring end gaps, right, for thermal expansion. That's why we have a gap on a ring, is so that not only can you install it, but also for thermal expansion. And because the rings rotate, you can have it where the end gap is aiming down. In the flat engine, now you have a leak path. In a V8 engine, it stands up, so it tends to go back down, it self-drains back. So in a flat engine, it's a little bit harder. You look at some of the OEMs, Porsche, for example, what they do is they put a locating pin about 45 degrees from the bottom. So you put, if on a clock, if you're looking at noons up here and 6s down there, at about 2 o'clock, they have a locating pin that locks the second ring in place. That way that end gap can never be down. And that's how they dam it up from the factory. Then and a lot of the OEM or a lot of the rebuilders, opt to go with a gapless second ring. We saw a lot of gapless second ring packages for, flat 6, flat 4, air cooled type engines for that very reason, that when you have a aftermarket piston that doesn't have a dowel pin to locate the second ring, you can rely on a gapless second ring to do it. So yes, it does matter the orientation of the cylinders based on that leakage.
Okay. So what viscosity oil should I use in a low compression, air cooled flat 4, approximately 60 horsepower road racing motor? Oil temperature is always between 200 and 220 Fahrenheit.
Ooh, good question. Well, really it's going to boil down to your bearing clearance. So more than likely that's an aluminum block engine. So it's going to have thermal expansion. So the other part of all of this is your bearing. So that's the oil film lubricated only, and that's where viscosity plays every role, right? That's it. You either have the viscosity right for your bearings or you don't. So really what will boil down to is what your bearing clearances are, just for some round numbers. So with that amount of horsepower, with that oil temperature, let's say you had a 2-inch main journal. If you had 2000 bearing clearance in that main journal, you could run 5W20 with that temperature and that amount of pressure. If you had that running clearance right now, if that with aluminum block, you're going to get expansion on the mains, not the rods, but the mains. And when that happens, you're typically going to grow a little bit. So maybe if you had them at 1.5 to start, they could grow and you can still run that 520. But if you're going to start off with say 2.5 cold, you're going to end up having to run probably a 40 grade, like a 10W40 or something like that, to be able to make that work.
Okay. Gentlemen, we didn't even have time to get to all the questions here today.
Really? Wow, that went
I know.
fast.
It's been about the fastest hour I think we've ever had. But if someone wants to find out more or they have questions, hey, what should I be using, either in my street vehicle or in a racing vehicle, Perry, Todd, could they reach out to Bestline, find out a little bit more?
Yeah, absolutely. We've got great websites you can click on. Perry and I are very reactive. If you send a question there, we'll answer it. I also wanted to make sure we're very clear to everyone. If you're one of these genius gurus out there that's invented something in your garage that you think is a great technology and you just don't know how to get it to the marketplace, call us, email us, because we're very good at commercializing newer technologies and we want to get it to the marketplace. But yeah, you can reach out to either one of us at our website, dnlchemical.com and bestlineracing.com, and we'll be happy to answer any questions.
Yeah, if you have anything that is specific to racing, I mean, Lake's been hands-on involved in racing motors and all that way more than Todd or I. So reach out to Lake at Total Seal.
Fantastic. Thank you so much.
Thank you very much, everyone. What a great webinar. Leg, thank you for coming back a little bit last minute. Reminded me that we did the first webinar together 2 years ago, and it's 238 now. So
That's crazy, Francie.
Thank you.
Time flies.
Yeah, it's 238. And next week is going to be 239. And we're going to be talking off-road racing with Kedimos Road and Race. Thank you very much for being with us today. We pushed Bestline product back on the homepage of the Epartrade platform. So again, we're live every Wednesday, but the platform is open 24/7, 365 worldwide. So take advantage of it, use it. We build it for you, the industry. So thank you very much for being with us today. We will be back live next week on Wednesday. Thank you very much. Let's go racing. Bye-bye.
Thank you.
Bye. Thanks,
Bye-bye.
everyone.
Registering on Epartrade is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use Epartrade as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to Epartrade.